Stoichiometry. Stoichiometry is the math of chemistry using moles and mole ratio in chemical reactions. For every stoichiometric measurement, we need units in moles and a balanced reaction. Using a balanced chemical equation to calculate the amounts of reactants and products is called stoichiometry. Mole ratios. In balanced reactions, the coefficients represent the number of moles required for the reaction to take place properly. We can make ratios using the stoichiometric coefficients, and the ratios will tell us about the relative proportions of the chemicals in our reaction. This ratio is called the mole ratio. So for this example problem, we are given 1.45 grams of tetraphosphorus solid, and it's being reacted with chlorine gas. How many moles of phosphorus trichloride is produced? So to figure this out, we need to use stoichiometry. These are the steps. Step 1 is to write the balanced reaction. So let's go ahead and do that. Step 1 to balance it. So tetraphosphorus P4 plus chlorine gas, we add the 2 because it's diatomic, produces PCl3. Now we have to go ahead and balance it. So let's see. There's 4 phosphorus on this side, and on this side there's 1. So we must multiply it by 4 to get it equal on both sides. So now this side has 4 and this side has 4. Next, we balance the chlorine. So on this side, 4 times 3 is 12. So we have 12 on this side, and we have 2 on this side. We have to multiply it by 6 to get it to 12. So we go ahead and place that 6. There you go. That's our balanced reaction. Step 2. Step 2 is to convert the given to mole if it's given in grams. So here we have 1.45 grams, and since it's given in grams, we have to convert it to moles. So let's use this triangle. We have to convert it to moles. So let's just cover the moles. So to find the moles, we need to divide this by grams per mole. But what is the grams per mole? Well, we have to go to the periodic table where it'll tell us how to find it. Okay. So, for phosphorus, there's 4 of them. So, the atomic mass for phosphorus is 30.97. And we multiply this by 4 because there's 4 atoms of it over here, as you see. So this equals to 30.7 times 4 equals to 123.88. So now that we know what the grams per mole is, we can figure out the moles. So let's just erase this because we don't need it anymore. And grams is 1.45. So let's go plug that in our calculator. Now the answer we get is 0.0117. 1.117 mole. Mole phosphorus, but yeah, just can write P. And so now that we have converted the given that was initially given in grams, and we've converted it to moles, now we can move on to step 3. So step 3 is to use the Stoic formula to calculate the required. So our required is the phosphorus trichloride, and we need to find out how many moles were produced. To do that, we have to use the stoichiometry formula, which is over here. So the formula says the given in the question in brackets first. So let's go ahead and do that in a different color. Okay, so given in the question is 1.45 grams. But remember, we had to convert it to moles, and every time you put it in this bracket, it has to be in moles. So we can put 0.0117 moles. So 0.0117 mole of phosphorus. Now we multiply this. Okay, first on top of this we have to put the required. Required is phosphorus trichloride. So we write phosphorus trichloride and given in chemical reaction. So these two always have to be the same. So we know that is phosphorus. Let's just put phosphorus under. And now we put the number, these mole ratios on top. So this one initially has a 1. We just don't write it, but it's there. So we just place that 1 here. And the PC, there's a 4 here. So just put that 4. And now go ahead and plug it all in your calculator to get the final result. 0.117 times 4/1. Like that. And the answer we get is 0.0468 required, right? Mole PC13. So I'm just gonna cross these out. So yeah, that's the answer. In chemistry, a reactant is called a reagent because, like an agent, it is responsible for something else occurring outside itself. Every reaction has a limiting reagent and an excess reagent. Limiting reagent: the reactant that gets used up first and causes the reaction to suddenly stop. Every reaction has this because if they did not, reactions would keep going on forever. The limiting reagent runs out because the amount required to keep the reaction going is not present at the time. Excess reagent: the reactant that is not completely used up in a reaction. Some will remain unreacted at the end of the reaction. Once you know the limiting reagent, the other reactant is automatically the excess reagent, which is the reagent left over. For this example problem, we have to find the limiting reagent and the excess reagent. So, to do that, let's follow these instructions. So, these are the steps for a limiting reagent question. And how do you know if it's a limiting reagent question? Well, you can identify that by seeing the given amounts. If you're given 2 given amounts, then it's a limiting reagent question. So since we are given 3.2 grams of oxygen and also 1.5 grams of hydrogen, we know that this is a limiting reagent question. Okay, so step 1 is to write the balance equation and convert all substances to moles, and then label these as the actual amounts. So let's start off with step 1, which is to write the balance equation. So the balance equation is the balance equation, it's oxygen reacted with hydrogen equals to water. So you know that. So now we have to balance. So now there's 4 hydrogens on each side and 2 oxygens on each side. So that's it. And then now we have to convert all the substances to moles. Okay, so substances to moles. So for oxygen, it's 3.2 grams. For hydrogen, it's 1.5 grams. And now we have to convert this. So let's start with oxygen. So we have to look at the atomic molar mass of oxygen, which is 16. Since there's 2 of them, we multiply that by 2, which equals to 32. Next, we go back to this triangle, and to convert it to moles, we have to do gram divided by grams per mole, which is 32 grams per mole. And what we get is 3.2 over 32, which equals to 0.1 moles oxygen. Now for hydrogen. For hydrogen, the atomic mass is 1.01 times by 2 again because of this 2 right here, which equals to 2.02. Same thing, use the triangle. So 1.5 grams over 2.02 grams per mole equals to, calculator, 1.5 over 2.02 equals to 0.7425 repeated moles H2. Okay, so now we need space to continue, so I will erase these, but I'm gonna write the actual ones on the corner so we can remember. So the actual for oxygen was 0.1 mole, and for hydrogen it was 0.7425 repeated mole. Now we can erase this. Okay. Next, step 2. Step 2 says to use Stoich and find the required of each reagent by pitting them against each other. Okay, so this step is like required. So we do each of them. So required for O, and then let's do required for hydrogen right here. So they're separated, like. And then we just do stoichiometry, which we did in the previous video. So you can bring out this. Kind of easy. We use the opposite one for the thing we're trying to find. So this one, we're trying to find O, so we use H. So for H, it was 0.7425 mole hydrogen multiplied by 1, 2. Remember, we use the 2 from the coefficient here and the 1 because there's always an invisible 1. And find that. And for this side, 0.1 mole, because from here we use the oxygen one. Oxygen. You multiply that by the other one. Hydrogen. So we write hydrogen here and 2, and under it we would put oxygen, which is 1. So now I'm going to go ahead and calculate them. So this one is 0.37125 mole oxygen. And this one is 0.1 times 2 over 1, which is 0.2 mole hydrogen. Okay, so now we're pretty much done. Step 3 says find the LR. So now we have to find the LR, which is also what we have to do. The substance where the required is greater than the actual is the LR. So let's see which one of these are greater than the actual. Well, 0.2 is not greater than 0.7. So it's O. This one, 0.3, is greater than 0.1. Required is greater than actual. So O is limiting. Because the actual is less than the required. And so we finished the first question, and the second one is, what is the excess reagent? Well, as I already discussed this before, we only have 2 reactants. So if one of them is the limiting reagent, which is the O, then hydrogen is automatically the excess reagent. So we can just write hydrogen is excess. Actual yield is how much you actually produce in a lab setting. Actual yield is always less than theoretical yield. Theoretical yield. It's the maximum theoretical amount that could possibly be produced. It is the amount that is calculated or predicted by stoichiometry. Percent yield is the ratio of product between what you calculated through stoichiometry, the theoretical yield, and what you actually get in the lab, which is the actual yield. Percent yield can never be 100%. This example problem is asking us, what is the percent yield of water if 84 grams of water is produced from 12 grams of hydrogen and excess oxygen? So let's see the steps for a percent yield problem. First step is to write the balance reaction. In the previous video, we already did this, so I just repeated it. Same one. Hydrogen plus oxygen equals water. And the second step is to find the LR. So we know that the LR is limited reagent is 12 grams of hydrogen because here it says excess oxygen. That automatically makes the oxygen an excess reagent, making this one the limiting reagent. So let's jump right into step 3. Step 3 tells us to use the limiting reagent to find the theoretical yield. So using this, we have to find the theoretical yield. So let's start with converting the grams to moles. So 1, 2, 3, oh, let me try. Over 1.01 times 2, because 2 equals 5.9405. Repeated. Mole of hydrogen. Now we can do stoichiometry. Put this over here. 5.9. Remember, it's required. It's asking us of water, so we put H2O on the top because that's what we're trying to find. And we put hydrogen on the bottom because it's the same, so they can cancel out. And the coefficients are 2 for each of them. So if you plug that into your calculator, you should be getting 5.9405 repeated. Same as this one, because 2 divided by 2 is actually 1, basically. So 1 times any number is that number. So this equals to mole H2O. Now the next part is we have to convert this back to grams. So to do that, use a triangle. Mole to grams, covered, you have to multiply by grams per mole. So the grams per mole of water is basically 18.02 because 16 plus 2.02 because 2 is, so like this would be 18.02, and then if you just add it all up, you should be getting 107.047 grams of H2O. And you don't really need to write this. Let's just say that it's 1.7, about 1.7. So now we've completed step number 3. The theoretical yield is 107 grams water. So now we're gonna erase this. I'm just gonna write that here so we don't forget. Step 4, the last final step, is to use the theoretical and the actual to calculate the percent yield. So here's the thing. This is the formula for percent yield. So actual over theoretical times 100. So the actual is given in the question itself. If you look carefully, it says 84 grams of water. So that's the actual, because that's what we had in the lab. So you write 84 grams. It's already given in the question for you. You don't really do anything. And then over theoretical, which we just found out here, 107 grams equals 84 divided by 107. And then we multiply it by 100. .58%. So this is the percentage you should be getting. Here we have delicious bread with the best cheese one could ever have. I know this makes you wonder, wow, this is so appetizing and I'm feeling so hungry all of a sudden. But what does this have to do with chemistry? Well, in chemistry, a balanced chemical equation is a recipe for a reaction. It contains a list of all the reactants, in this case, the ingredients, which is the cheese and bread, and products, which is the grilled cheese, as well as their relative proportions. Using a balanced chemical equation to calculate amounts of reactants and products is called stoichiometry. If you were almost out of a specific ingredient, you could use the principles of stoichiometry to figure out how much of every other ingredient you would need, treating the ingredient you were almost out of as the limiting reagent. Here, for example, we're trying to make grilled cheese with slices of cheese and bread. Suppose we were making 4 for 4 different people. We need 2 slices of bread and 1 slice of cheese for each sandwich. But here, we only have 3 slices of cheese, but a lot of slices of bread. So here, cheese is a limited reagent because we ran out of it before the bread. We can't make 4 sandwiches, even if we cut the cheese, we can't. Because we need 1 full cheese and 2 slices for each sandwich. In that case, bread was the excess reagent.